Hello students. So today we'll do some problems based on application of derivatives. Okay. So first example, show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius a is 2a upon root 3. So here there is one sphere. Okay, and its radius is a, and one cylinder is inscribed in that sphere. Okay, this is the height, full height. This is the slant height, or we can take here triangle. Okay, so this length is a. Okay, full total height is h, so this portion will be h by 2, correct? Or we can take some like x. Okay, I'll write here x. It will be easy for to calculate. Okay, so our height is 2 times x. Okay, so we have to show that height of this. What is the volume of the cylinder? Pi r square h. Okay, so we have here radius we can find by using Pythagoras. Okay, so using Pythagoras, a square is x square plus r square. Okay, so radius is this, we have taken r, a square minus x square. Okay, that we can substitute here. So this will be, in height, total height is 2x. So this is our volume. Okay, now we have to find the maximum volume. To find maximum volume, first you have to derivate this. Okay, differentiate, put it equal to 0, then double derivating. After getting the critical points at first derivative, you have to put it in the second derivative. We have to look for maximum and minimum, right? So we are going to differentiate this because a is fixed, right? The only thing which is moving here is x. X is unknown, right? So we have to differentiate with respect to x. Okay, if I take this x inside, it will be correct. So the derivative is okay. So this we have to put it equal to 0. So this will be we want x, right? Root 3. So x we got a upon root 3. This is the critical point. Now we have to differentiate this again. Okay. So 2 pi a square becomes 0, 6x. So we will get minus 12 pi x. Okay. At x equal to a upon root 3, this value is a upon root 3. So this is going to be less than 0, right? Less than 0 means maximum. So maximum. Okay. So the point x equal to a upon root 3 is point of maximum. So now we have to put this x is a upon root 3. So this is our x value, right? And we want to find the height of the cylinder of maximum volume that can be inscribed in a sphere of radius a. So height, we want the height. Height is our 2x. X is a upon root 3. So this is the height we are getting, which is same as which is given. Okay. Next question, of all the closed right circular cylindrical cans of volume 128 pi centimeter cube, find the dimensions of the can which has minimum surface area. Okay, now here first thing is cylinder. Okay. Cylindrical cans of volume. Volume of the cylinder is given 128 pi. Okay. Find the dimensions. So for a cylinder, you have a radius and a height, right? So both values we have to find when the surface area is minimum. So what is the surface area of a cylinder? Total surface area of a cylinder is curved surface area, that is 2 pi RH, plus the two circles, that is 2 pi r square. Okay. So we have to make use of the volume. Volume is pi r square h. So we can cut pi. So we can write this as in terms of r only by substituting here h, and that h we can take from here, or you can substitute r, okay, and make this in terms of h only, so that when you are finding out the minimum or maximum value, that time you will get one of the dimension, that is r or h. Okay, so write this as h equal to 128 upon r square. Okay, I'll substitute this here. So it will be h plus r 128 upon r square plus r. Okay, so now we have to make this surface area minimum. You have to find the minimum value. So first you differentiate. Okay, now here r is changing, so we have to differentiate with respect to r. Okay, so if I take this r inside, 1 upon r is to minus 1, so minus 1 r square is 2r. Okay, so we have to put this equal to 0 and we have to find the value of r. So this is so r cube is 64. So r is cube root of 64, that is 4. Okay, so we got the value of r. Now you have to check for maxima and minimum, maximum and minimum. So find out d square s by dr square. This, so 2 pi minus, so 2 plus 2 upon r cube plus 2. Okay, so here you have to put the value r equal to 4. So this is obviously going to be greater than 0. Okay. It shows that this r is equal to 4 is a point of minimum. Okay. So we got the value of r. Now we have to find the value of h that we can find by using this equation. So h is equal to 128 upon 4 square. H is 8. Okay. Mostly the problems are like this only. That is either the volume is given or the surface area is given. Then we have to find the maximum or the minimum. Okay. Same steps you have to follow. Next question. Show that the surface area of a closed cuboid with square base and given volume is minimum when it is a cube. Okay. So here surface area is there, volume is there, and when okay, so it is given that the cuboid is with a square base. Okay, so suppose this side is x, then our length is x, breadth is x, and the thing which is different is height. So height say y. Okay, then how volume is written? Volume is length into breadth into height. Okay. So x into y square y. This is our wall. Okay. Then surface area 2 times length breadth height length. Xy and xy. Okay. So this is volume, this is surface area. Now they have given that show that the surface area of a closed cuboid with square base and given volume is minimum. Means surface area we have to show minimum. So we have to differentiate this. Okay. Now we have here two terms x and y. Okay. So we have to write this in some one variable, that is either x or either y. So we can make use of volume. Okay, this volume is fixed. So this is like a constant. So we can write y equal to v upon x square. Okay, so substitute it in this. Okay, now differentiating with respect to x, this becomes minus upon x square. Okay, so putting it equal to 0, we'll get the value of x. X cube is v, so x is cube root of v. Okay, now we have to find maximum or minimum, so differentiating again this thing, 2, this will be plus 2 to the 4 x cube. Okay, this is what x is to minus 2. So minus 2 into x minus 2 minus 1, so minus 3. Right, so this becomes minus 2 upon x cube. Differentiation. So at the value you have to put x equal to cube root of v. So in place of x, it is cube root. So this and this gets cancelled. A and B also gets cancelled. So 2 plus 2, 4. So this is greater than 0. So we have the minimum. So this is the point of minimum. Okay. So we have reached here. Now you have to find x we got, right? You have to find y. Y is v upon x square. Three. Or we can write v is x cube, correct? So I can write here in place of v x cube. We'll get the same thing. Either it is in terms of v or in terms of x. So we are getting here y equal to x. This means that all these three things are equal. When all this length, breadth, height are equal, then it is a cuboid, correct? So the surface area is minimum when it is a cuboid. Not cuboid, cubed, sorry.